I don't like the formula method for performing site reductions, but it is just as valid. So we're gonna make this video short. We're only gonna do one of the examples. So I chose the 4th of June example. And it's, like I said, Pub 229 is just a table that was created by performing this formula calculation, for every possible combination of LHA, assumed latitude, and declination. So you're ultimately going to get the exact same information. It's just, some people would argue more precise. I think it's more work, and there's more opportunity for error, because if you're not good at using a calculator, you could get, one little parenthesis wrong and it'll mess you up. But we have two formulas listed on page 25 of the introduction section right here. And you can see they're very similar to the great circle formulas for determining course and course angle of a great circle. I think there's something like in the azimuth formula, I believe one of these signs is a tangent in the great circle version, but otherwise they're almost identical formulas. So we'll write the HC one here. You can see it is the sine of HC is equal to the sine of L, or assumed latitude, times the sine of D, or declination, plus the cosine of L, cosine D, cosine LHA. And then the azimuth formula is the tangent of Z is equal to cosine D sine LHA, cosine L sine D minus sine L cosine D cosine LHA. Again, a lot of opportunity to get something wrong. Now, there are two rules you need to remember, and they're both pretty similar to the rules for great circle sailing. Firstly, if your latitude and your declination are contrary name, just like they're listed in the book as being different if they're contrary, you have to set declination as negative just for the math to work. That's why the two options are split up in the book. And it's just like setting your second latitude as negative if you cross over from the north to the south, or the south to the north in a great circle sailing. And then nextly, you can see here, our answer is Z, not Zn, so we're going to have to perform that correction at the end as well. Is that, I don't believe there's another issue for the LHA. There are explanations here. I believe there might be something special about LHA sometimes, but I don't think it. I think we're good. Okay, so we're going to do this same problem again, but we're going to use the formulas instead. So we'll start with HC. So our sine of HC is equal to the sine of L, L being 27, times the sine of the D, which is 20. Remember, negative here because we're going from the south and the north, so 22 degrees, 28.2 minutes, plus the cosine of 27 times the cosine of negative 22 degrees, 28.2 minutes, times the cosine of 317. We'll plug that in. We get sine of 27 time, and then this calculator isn't great with minutes and seconds, so I have to do it manually. Plus 22 times negative 1. Okay, sine of answer. So we just did sine of 27 and the sine of 22 degrees, 0.2 minutes negative. We multiply the two together, and that's our first term here. And then we're going to do cosine of 27. Cosine of, I'll pull it from my memory, the negative 22.47. And cosine of 317. Then we'll multiply those three together. And that's this term. And now we're finally going to add that to the first term right here. Get 0.42, and we do inverse sine. Answer 25.38. HC is equal to 25.38. Remember, this is degrees. We have to convert it to degrees and minutes because that's what we're actually reading off of our sextant. So we'll subtract the 25, multiply 38 by 60, and we get is equal to 25 degrees, 22.9 minutes. And if we want to double check, we can come to our 4th of June problem, and we got from the book 25 degrees, 22.9 minutes. So they perform the same thing. They will get you the exact same answers. It's up to you whether you think the formula or the book are easier. So now we're going to do for the azimuth. So tangent of z is equal to cosine of the declination. So, oh my God, negative 22 degrees, 28.2 minutes times the sine of 317. For the cosine of 27 times the sine of negative 22 degrees, 28.2 minus sine 27 cosine negative 22 degrees, 28.2 minutes cosine 317. And now that we have that, we got to put it in again. So just going to do recalculate the declination there, multiply by 1. I'm going to store this as x so we don't have to keep doing this. Cosine of x times the sine of 317. And we're just going to keep that off to the side. Cosine of 27 times the sine of x. Good. And the sine of 27 times the cosine of x times the cosine of 317. Now remember, it's this minus this, so we have to pull up this term first, then subtract it from that term. Now that we've done that, we go up to the top term, divide it by what we just got, 0.97, we do tangent inverse, we get 44.2, which if you look back at the June 4th, maybe I was wrong, and you don't, it does actually give you Zn automatically. You don't have to do the corrections. So it automatically pumped out Zn is equal to 044.2 degrees. And then we would have our HC and our Zn, both equivalent to what you would have gotten if you had gone in the book. Just if you like it more, you like it more. I know some teachers will require you to do both and demonstrate doing both, just to prove you have the understanding. But after I got through my Sonite class, I never went back to using the formula. I only ever used the book.